Hello and welcome back to another video. This problem, we're looking to find which of the following complex numbers is equal to 5 plus 12i, just rewriting it, minus 9i squared, and then minus 6i. So the first thing we're going to want to do is get rid of these parentheses. So for this first one, there's no coefficient, so we can just rewrite it as it is without the parentheses. 5 plus 12i. And then for here, we're subtracting these next parentheses. So in this case, you could think of this as having a unwritten coefficient of 1. So when you're distributing out this 1, it doesn't actually change anything, so you can basically just ignore it. But here we have a negative 1 as a coefficient. So when we're distributing out, negative 1 times 9i squared becomes negative I squared. And negative 1 times negative 6i becomes plus 6i. Thinking of it as a coefficient of negative 1 might make it easier to remember to distribute the negative, which is basically what we're just doing here, right? So then when we're combining like terms, we have 5 minus 9i squared. Those are both don't have anything to combine with. And then we have plus 12i plus 6i. So plus, and then 12 plus 6 is 18i. And this is equal to this, but it doesn't line up with any of these, right? If you notice, none of these terms have an I squared term, but our final answer does. And this is where we're going to have one more step of simplification. If we know that I is equal to the square root of negative 1, then I squared is equal to the square root of negative 1 squared. The square root of anything squared is negative 1, therefore I squared is equal to negative 1. So we have 5 minus 9 times I squared, which means it's times negative 1 plus 18i. Then we have 5 minus 9 times negative 1. The negatives cancel, so you have plus 9, and then plus 18i. Last step, 5 plus 9 is 14, plus 18i means that D is going to be your final answer. As always, thank you for liking and subscribing, and I'll see you in the next video.